Today we are going to introduce the data transformation part. Let me start with my slide. Yes. Okay, pen. Okay, so like I said, data again classified into two at a very high level, if you wanted to remember. The one is storage part, the other one is transformation. And I think within storage, we have covered Azure storage accounts. We have covered Azure Data Lake. We have covered Azure SQL. I think yesterday we almost covered Azure CosmosDB. There is one last topic which is pending on this, which is consistency, which I'm going to explain today's session. So that we'll also cover this one. And then the data storage part is done. So we'll be done with this guy. So then we have very interesting session here, right? And I think there is one, okay, from Vineet, he says, if time permits, can we have some hands-on session? Yes, definitely we can have, because we'll be having some lengthy sessions on weekends, so we can do that. The reason we haven't really done like more hands-on or experiments or lab sessions with respect to storage, because there is nothing more to do in this. These are like pretty straightforward one-time activities, right? But when it comes to exercises, when it comes to hands-on experience, so you need to spend more and more and more time on data transformation, because being as a data engineer, you'll be writing more and more expressions, creating more and more pipelines on the data transformation part. But on the storage part, I don't really think there'll be huge work, because you might define the format and then you store, then you dump the data, right? So the storage part is automatic and everything is done by the Azure itself, and the backend, you don't really have more visibility there. But when it comes to transformation, yeah, of course, you have so many labs. I mean, we might do few labs in our sessions, right? Just to make you understand, but you have to do on your own, right? We will give you a starting point and then you have to take from there and then try to explore more and more. We'll also, of course, provide you all the reference links and everything, which are related to Microsoft, the official documentation links where you can get all the labs and everything. So this is where you try to appreciate the transformation part when it comes to Azure. Being as a data engineer, you have mainly 4 tools, right? So I think this, you don't really work much on this HD Insight, but when it comes to transformation, you have Data Factory, you have Stream Analytics, you have Databricks. I think this is really cool. And again, we have this Azure Synapse, right? We'll be discussing the reason why I put in middle, because it's a combination of all these components or modules, however you want to call them. So definitely, Vinit, we'll be doing some lab exercises so that you get the feel of, okay, I have done something, I have worked, I have designed. It's not like I'm only talking only theoretical. I'm putting everything in layman and simple terms. You might feel, oh, this is really easy. Being a data engineer, the work will be this easy. No, it won't be this easy. Trust me. You'll have complex pipelines which you need to design, of course, based on the requirement. So we will get there. We will get there. Okay, so let me move forward then. Yes, real-time experience. Definitely, Ashish. Okay, moving forward. Yeah, like I said, right? So I just want, for me, I like making things easy, because the reason we have designed, I have designed this in such a way because I wanted to make them easy for you. If I wanted to put more technical terms, if I wanted to make it more complex, I can do that. Only just going to the Azure portal and showing everything to you, and it might be a little bit confusing for you, because you need to have a starting point, you need to have a middle point, you need to have an ending point. We will try to give you a starting point and middle point. The ending point, you need to figure it out. But when it comes to certification point, I think whatever we are covering, because it's not one topic, right? You might not get questions only on NoSQL. You might not get questions only on Azure Data Factory. You will get questions in a scenario-based situation where all the components might be involved. Being as a data engineer, they'll give you a scenario-based questions. They'll ask you that, you have all these components and you need to define this. So what is your suggestion? What is your advice to the customer? So these kind of questions you might get. And the other reason why we haven't really done like more labs and all, because there won't be any code-based questions. You don't really get like, you have code, please fill in the blanks. You might get 1 or 2 questions. Even if you don't really prepare for them, you can still clear the exam. But yeah, to work as a real data engineer, you need to have that programming experience. When I say programming, it's either SQL or Python. And if you have both, that's really great and amazing. Okay, so NoSQL, CosmosDB, right? For me, when it comes to NoSQL, the main components, the important aspects we have within this module is types of API, which we have covered, and we can also call it as like a multi-model. You have 4 different types. And then you have RUs, you know what are RUs, request units, the metric, right? And then we have covered this, and then you have partitioning. We also seen what is partitioning and why it is really important when it comes to NoSQL, why you need to understand about partitioning, and why it is really important for you to define the right key as a partition key, right? We have seen that, and we have seen TTL, time to live. So you can also define this so that, you know, after a certain period, you can delete the data. I think if you try to remember, right, time to live, that's what we call in Cosmos DB, but we also have the same feature when it comes to storage accounts, life cycle policy, life cycle management, right? So there, using life cycle management, you can define that after these many days, boom, delete the blob, delete the storage. The same concept, but the name is a little bit changed here. You call them time to live. There you call them, you know, life cycle management when it comes to data lake. And then consistency level. So this is the concept which we're going to see today. I don't think it will take more than 10 minutes. Once this is done, once if you try to focus here, right, when I'm explaining, once this is done, then I'll hand it over to Vishwamitra. So I completely understand you guys might have like really bored and, you know, with all my sessions, more theoretical, right? So Vishwa will jump in and we'll start data transformation part where he'll try to explain about data factory and all. We'll see how it goes. Okay, so what is data consistency? Like I mentioned in the yesterday's session, again, let me go back to the portal. Okay, so here, replicate data globally. So I think this is, let me close this one. Okay, so I think this part we've already seen in yesterday's session. We know what this guy is, what they do here. So this part here. So if you see here, you have our data centers, our NoSQL databases completely distributed in different regions, okay? And while you creating, you will define a location, a region, that's your primary location. So then later you figured out, okay, I need to add, just a second, guys. Okay, my door was open, sorry. So then later on you realize that, okay, so I need to add more business continuity going forward. So I need to add high availability, I need to add disaster recoveries, and then slowly you wanted to add this because these are really mandatory things when it comes to designing a storage layer. So then what you have done is you have selected different regions based on your customer base. So let's say your more customer base are located in India, then you have selected Central India, and then you have a customer base located somewhere in Middle East, UAE, then you have selected that region, right? So then you have added them, and then what you have done is you have saved it. So this is called multi-reads, right? So your primary location will be the only location where your users will be writing the data, right? Storing the data, and you can use the other regions to read the data, right? So these will be acting as a read regions. Okay, so this is what we have seen in yesterday's session, and we know these are called multi-reads. So when it comes to multi-writes, right, you also have another option called multi-writes here. So what are multi-writes? So let's say for whatever reason, the primary location, right, it's gone. For whatever reason, it's gone. So now you wanted to have like a DR. Now you wanted to have like a disaster recovery plan. Because one is gone and now you wanted to again upload the data, right? Because you don't want to stop it. Maybe there is some data which is coming from users and all that data is gone because your system is not responding because it is out of order. So in that case, you've also enabled selected few regions and you have enabled multi-region writes. So usually here the multi-region writes, right? So once you have selected the multi-reads, see automatically the multi-region writes will also be applicable to the same regions. So the only thing you have to do is just click on this, because by default it will be disabled, then you enable it. So for primary region, you have 400 request units, which you have selected while creating this. And then automatically for the remaining regions, for the remaining multi-write regions, right? For the remaining regions, it will automatically add each region a 400 request units. So here you need to be very careful with respect to cost and price, because you are adding more regions. It means you are adding multiple 400 request units. And then based on that, you'll get your bill. Okay, so this is what we have seen so far. So now the problem with this thing is, the problem we have with this is, let's say the user from this location is trying to, let's say the user from this location is trying to update some data to West Europe. And the other user from Central India is also trying to update some data or insert some data. Okay, and another user from a different region is trying to read that data. So now here the problem is which insert or which update will take the precedence. So how you're going to give the priority for the end user to read the data. The end user might be in this location or the end user might be in some other location. So here you need to maintain that consistency, right? So you need to have the data consistency. So that is what we're going to see in the consistency. So when it comes to NoSQL, CosmosDB, we have total 5 consistency levels. I think if you try to compare this with AWS, I think we have similar concept in AWS as well. I think for DynamoDB, it's a NoSQL database in AWS. So even there you have the similar concept like consistency. So if you want to relate to that, but here for that issue, we have, I mean, this is again an issue, right? So for this issue, to address this issue, we have a consistency concept. We'll say what it is. So by default, like I said, you have total 5 types of consistency. So you have strong, bounded staleness, session, consistent prefix, and eventual. And you also have a little visual, component which they have added, especially Azure has added here, so that to understand the different types of consistency. So based on this, you can literally try to understand how this consistency is working. Maybe I'll try to explain based on this scenario so that you'll get better understanding about it. So how to start this? Let's start with by default, the strong is disabled, and by default session consistency is enabled for you, because session consistency is most widely used consistency level for both single region as well as globally distributed application. Okay, so here if you see, we have enabled multi writes and multi reads here. So it means it is globally distributed. Here the data is globally distributed for us. Okay, it's no more a single region. Of course, while creating, I have added just a single region, but later on I have added multi reads and writes. So then it is termed as globally distributed. So now my data is globally distributed in different regions. So in this situation or in this scenario, by default, right, by default, Microsoft recommends to use session. Again, what is session? What is consistent prefix? We will see that. Let me start with the eventual then. Okay. So understand eventual consistency. Let's try to read what this definition here is trying to say us. Okay. So in the absence of any further writes, the replicas within the group will eventually converge. Okay. Eventual consistency is idle where the application does not require any ordering guarantees. Okay. Example includes retweets, likes, non-threaded comments. Okay. Did you get the point? No, it's kind of confusing, but let me put it in simple terms. Okay. So let's say you have central US writes, central US reads. Okay, central India writes, central India reads. So I think for each region you have like writes and reads, because these are the regions which you have enabled. Okay, let's try to focus on central US. Just focus on this guy. Just try to focus on only these two things. Okay, so in central US writes, let's say the data is getting updated in this order: the red, blue, violet, dark blue, green. Okay, just try to focus the coloring order here. Okay, so the writing order is this, and if you see the reading order, so usually it starts with red, but here the reading order is not starting with red. It means the order is not maintained here. Let's say someone has added the data red. Let's say they have added some data where the color is equal to red. If someone is trying to read at the same time or after a few milliseconds, he will only read green. He won't read red because here the order is missing. See, after green, he might read red. I mean, you don't really have like a huge difference here, but there'll be like very millisecond difference. But here what he's trying to say is, so here the consistency, of course, the consistency is like, eventually maintained, but the ordering is not guaranteed. Okay. So that is the main thing which we need to understand here. I hope I made it clear, but just keep this in mind when we try to understand different items. Maybe this will be very clear for you. Okay, so the writing order might not be the same as a reading order. Okay, again, writing might be in this region, and again, if someone is reading the same region, if you see, the order might not be the same. So the reading order might start from orange, and all these previous items might not be in the same order, but they will eventually read. The name itself says like eventually you will get the data, but you get it eventually, not at the same time, and the order is also not maintained. So for the examples, right, the use cases for this is, let's say, in social, for example, the social networking, right? In social networking like Twitter and all, if someone is like trying to retweet, I mean, at the end of the day, tweet has to be posted there, but you don't really care the order, right? I mean, like you and your friend are trying to post it. Maybe sometimes yours might be a little bit faster and his might be a little bit slower. So in that case, the ordering and the consistency is maintained in eventual. Okay. So this is the least build consistency level. Okay. So here the cost is very less compared to different consistency. So if you try to see the cost gets increased in this order. This is the least, eventual is least, then you have consistent prefix, a little bit higher cost, then you have session, that is again a little bit higher cost, then you have bounded staleness, then you have strong. Strong, we will see that, but usually if you see the costing order will be in this order from left to right. Okay. So this is about eventual consistent. Again, if you try to see that, for all the different regions, it will be like that. So one thing you need to remember is eventually you'll get the data, someone who is reading, but the order is not maintained. What is consistent prefix? Okay, let's try to read what they are trying to say here. So here, if writes were performed in the order A, B, C, let's say if someone is trying to write data A, then data B, then C, this is the order they have written. Then the client sees either A, AB, or ABC, but never out of order. I think it's pretty straightforward and self-explanatory, the same statement, right? So here again, the data will be eventually there, but the order will never be skipped. Okay. So let's try to focus on this guy, on this example. Again, someone is trying to write red, blue, violet, then green, let's say. And if you see, when the user is trying to read, he will read first red, then blue, then maybe there is some gap in between. He might not read immediately, but again, he will read the next one because here the sequence and order is maintained. Okay. So the order will never be skipped. So that's the main difference between eventual and consistent prefix. Here it says the consistent. It's like, the order is maintained with the prefix. So consistent prefix provides write latencies, availability, and read throughput comparable to that of eventual consistent, but also provides the order guarantees. Okay. So use cases, maybe you can try to, imagine yourself in which use case this can be suited based on your needs. But usually wherever you need the order, in those situations, you will try to use consistent prefix. The only thing you need to do is, anyway, you have already created a replicate globally, right? You have already replicated your data, geo replication. One thing you need to do is come here, click on that and save. Automatically it will be saved. Okay. And then we have session. So it provides write latencies. Okay. So here the thing is, this is like session based. Okay. If you see here, send till from, okay, let me zoom in a little bit. So here, if you see central US writes in session A, let's try to put them in two different sessions. One is session A, and there is another session, which is session B. Okay. Which is in North Central US. So all the data in session A will be completely consistent. Okay. Writes and reads right at the same time. So someone is writing something in Central US and immediately, I mean, there'll be like very, very millisecond latency, but if you see, there is almost same, it's like negligible. And if you see here, the writes and reads are done at the same time and the order is also maintained. However, the user is writing the same order, the other end user is reading the data. Okay. And that is within this session. And there is another session. This is completely out of sync and out of order. If you see the session B, but again, the order is maintained. The only thing is the session, the other session, you will have some latencies while reading the data. That is the definition, and that is the difference between session and consistent prefix. Okay. So then you have bounded staleness. So what is bounded staleness? So here you have an opportunity by yourself where you can define the lag or the delay. So you can tell to the systems that, for me, if there is like, 5-second lag is fine. I mean, that is the maximum lag I am trying to put here. So between the read and write. So if there is like, 5 seconds of lag, it's okay. And again, this lag is not consistent. And again, what I'm trying to say is like, it's a maximum lag. So it might be within 1 second, it might be within 2 seconds, maximum it won't reach 5 seconds. Okay. So here you are bounding that, you are adding a boundary saying that this is the maximum lag you can have. So if I see here, for instance, if you see here for these two regions, okay. You see between this guy and this guy, there is like, 5 seconds of lag. I mean, that's the maximum. It can be within 5 seconds. Okay. and that happens with any one or two of the regions, and the remaining regions you will get like eventual consistent like session bound. But for one or two regions, and it automatically detects and selects it. Okay, like I said, there are some paired regions, and whichever region which is out of that paired region, it will find it out, and for that region it will act and it will apply all the bounded staleness. Okay, the only thing you need to remember is bounded staleness. You have an option where you can define the lag, right? Lag or delay, call whatever you like. And there again, the order is maintained, but this is the time where you have a latency difference. Okay, so that's the only difference. So again, I think for this, the strong is disabled. So usually the strong is nothing but, the user is writing and you will get it in the same order, same sequence, right? But here the price is high when it comes to strong. And again, for one or two regions, even for strong, you might have a little bit of latency. Okay, so if you try to compare, or if you try to compare all of these consistency, so eventually is the cheap is the less priced one, and the strong is the more priced one. If you wanted to go in this direction, so it's strong, then it is less, and then it is session is less, and then it is less, and then it is less. So this is in this order. If you want to go into this order, then you have like eventual, then it is a little bit higher, then higher, then higher, then you have everything written, which is everything is red, which is written. That's nothing but strong consistency. So why I'm trying to stretch this, and we have almost spent like half an hour. So why did we do that is because you should expect either 2 or 3 questions from this consistency. So the questions might be, few questions might be very straightforward, few questions might be series based, few questions might be scenario based, and there'll be like again combination. You don't really get like so you have a NoSQL database, and so now you wanted to have 2 sessions, and within session B there is some issue. Which consistency? No, it won't be that straightforward. I think I'll try to provide few questions in the Slack so that you get better understanding. But few questions are expected from this. I don't know why they wanted to stretch this, because this is a really important concept even when you're trying to work, right? Because this is the limitation we have, and for that limitation they come up with this solution. Maybe they might add more consistencies, but for now we have only 5. Just try to understand this. Let me pull out my PPT. So I think here, yeah. So here the replication, let's say if you take 5 seconds of, if you take 5 seconds of lag here from West US to East US, right? So at 10 a.m., someone has updated credit score as 750 in this region, okay? And someone from East US region is trying to read at 10 after 2 seconds, okay? But let's say for this to replicate, it takes 5 seconds, for instance. So at this 2 seconds, right? At this 2 seconds, this user will read the old data, right? Which is already stored in the database, because if he's trying to read the latest data, or maybe based on the condition. But when it is strong, right? When it is strong, it will try to wait for 3 seconds. The system will try to wait for 3 seconds. It will retrieve the latest data. Then it will try to show it to the user. What I'm trying to say is when you try to retrieve at a 10-2 seconds, you still have 3 more seconds to get the data, to get the replication. Because the system knows someone has already updated the data, because these two systems are already in sync. But the only thing is it is not replicated, because the system is saying that, oh, to replicate, it takes 5 seconds. The system is saying that, I'll take 5 seconds. But both the systems knows there is service which is running in the backend that, oh, something is updated in system A. But now to have that value, I'll need 5 seconds. But now the user is asking me the latest value after 2 seconds. So do I need to wait 3 seconds to give him the latest data, or do I show him the data what I already have? So if you choose strong, you will wait for 3 seconds, sit in front of your system, like, after hitting your query. Then after 3 seconds, you'll get the latest data. That is called strong. Okay. I mean, this is an example just for you to understand, but usually it won't really take like 5 seconds or 6 seconds. It will be like very milliseconds or microseconds difference, but just to make you understand. I think we have one-line definitions here. So like I said, strong consistency, higher latency, lower availability. Lower availability, when I said what lower availability means is, so when the user is requesting after 2 seconds, he has to wait for 3 more seconds because the data is not available yet, because you have selected strong. Strong will make sure that you will get the latest data, brother. it will fight for it. I mean, it will fight for you that, I won't give you the old data. I will give you the latest data, because some user from some different region has updated the data. I'm going to make sure that you will read the latest credit score so that you can provide him the loan. I won't miss it. I'm going to help him because he needs loan. Jokes apart, so Strong will help on that, but here the data is not available right at the moment. So if you try to go in this direction, here the consistency is less, but here the data is available because, guys, in the eventual, it will give you whatever it has. It doesn't wait. Okay, so one-liners, Strong, no dirty reads, high latency, cost is high. Like I said, this is high, then it is low, little low, and this is cheap. This is close to RDBMS. It acts like a transactional database. Okay, and bounded staleness, dirty reads possible, bounded by time and updates. Like I said, you can define that boundary, lag or delay. And then session, no dirty reads for writes. Within the same session, everything works fine, but outside the session, you have dirty reads. Dirty reads is nothing but lagging and out of order. That's nothing but dirty read. Then you have consistent prefix. So here, dirty reads are possible, but here this guy is saying that I will maintain the order, I will maintain the sequence, no matter what, I'll maintain the sequence. That's what he's saying here on the consistency prefix. Okay, and eventual, here no guaranteed order, but eventually everything gets in order. That's what they say, but here the order is not guaranteed. Yeah. Okay, so this is all about consistency, right? And if I go back to, I think here, I don't want you to go back. Okay, so like I said, we have discussed almost all the important concepts with respect to NoSQL. So here we have only selected SQL core API, but I would suggest you guys to play with other APIs. Just try to create different APIs. Almost you should see all the other concepts or all the other available modules should be same for other APIs as well. The only thing, like I mentioned, that the way there is like very slight difference between these different types of data, and when it comes to graph, you have different naming convention, but again, at the end of the day, you have key value pairs there as well. So I would strongly recommend you guys to just play around with it, because you don't have any limitations or restrictions there. Just try to create with different APIs, get that feeling that NoSQL, CosmosDB. If you wanted to initiate some discussion with your management or with your colleagues, so that you get that confidence, right? Try to go through this. That will be my recommendation. But whatever the information or whatever the knowledge you needed to clear the certification, I have included everything. So I don't really think you get any question out of the scope, right? And there is another concept, which is monitoring. I think we've already seen this. There is one thing, log analytics, which we haven't seen. I think we'll see this in Synapse, but the rest, everything is same. Insights, you go to Insights and you see all the stats, everything in the form of graphs. Okay. But here it will be requests based on the request units. Then you can create alerts, right? Like we discussed, you have alerts, then you have metrics, then you have a diagnostic settings. Like I said, Azure monitoring service is full stack monitoring service, which is embedded in each and every service in the sense like all the components. So with this said, I think we are good with this. And remember that you have this data explorer thing. I haven't like really added most SQL queries because I understand that this is like very basic. I mean, you guys are already, familiar with SQL. That's my understanding, because, when you guys have signed up for data engineering, at least this is like something which you should be aware of. If you don't know SQL, no worries. Like I said, we'll try to accommodate a crash course on SQL and Python at the end. If that is not possible, I'll try to provide you the links where you can find very basic beginning to intermediate level of SQL and Python, which is more than enough for you to be and start as a data engineering role. And then you have scales and settings. Like we said, we've discussed time to live. Then you can also change your scaling. But I think this is what you need to know. Here you have notebooks, right? Where is this guy? Yeah, here you have notebooks. We haven't really discussed about notebooks. The reason behind that is we have data breaks, we have Azure Synapse Spark Pool. So we have so many concepts which we are going to see in further sessions. So there we'll discuss more about notebooks. Once you get familiar with notebooks there, then you will understand, oh, what we have to do here in this. So either you can use SQL, you can use notebook. With notebook, you can write your Scala code or Python code. So with this, I will hand it over to Vishwamitra for him to start on the data transformation. So today we are going to start the first component within data transformation, which is Azure Data Factory. Guys, this Azure Data Factory is really important. And I think once at the end of the session, you'll really appreciate all the features we have within that. If you guys are familiar and if you're coming from ETL background, right? Or if you're coming from PLSQL or SQL background, you can really relate that with your past experience.
So let's start. Uh, so here we are going to deal with Azure Data Factory. So basically Azure Data Factory, you can think it of as a ETL tool. I don't know how many of you have had a previous experience with ETL tools. Basically ETL stands for extract, transform, and load. So it is we can do the ETL process using programming languages such as Python, using pandas packages as well. But majority of the companies out there are using tools like SSIS, which is sponsored, which is actually whose vendor is actually Microsoft. There are other tools such as Pentaho, uh, Talent, and many more. So what is ADF? ADF is actually a cloud version of that ETL tool, and Microsoft as already has a data integration service called SSIS. So it is similar to that, but in the cloud version. Okay, so what you can do here is it allows you to create data-driven workflows. Like you can create a number of transformations. You can ingest the data from a number of sources. In EDF, it supports more than 100 sources of data, as in it can be your flat files, it can be your let's say in as Vinod has already taught you about uh, blob storage. Azure blob storage, it can act as a data source. Azure SQL database, it can act as a data source, or you can also have some Excel files and many more. And then on top of it, you can do the transformations. And transformations as in, like, for example, you have a set of data, but you which contains all the details of your customer code, customer name, product ID, like that. But you want to do some transformations on that data, and you want to say, let's say a product comes appended with customer code, comma, customer code dash, and your product ID is there in the product code column. So you can do transformations like that. That's a very simple one, but there are many more like that possible. And ADF facilitates this in cloud. ADF In ADF, we can also create and schedule data-driven workflows, which are called pipelines, which can ingest from a number of data stores. We can also build complex ETL processes that transform data visually with data flows by using compute services such as HD Insight and Databricks, Synapse Analytics, which will be taken on later on in the course. ADF also act as an orchestrator. So orchestrator, as in you can think it as a scheduler as well. And normally, when we have an ETL tool, an on-premise ETL tool, we guys mostly use some other or schedulers, or some other tools to schedule all our data, ETL code, ETL pipelines. So ADF has a facility that it also act as a orchestrator. So in the figure uh, you can see there is a relational data, there is a non-relational database, all your structured, non-structured unstructured files, and all your databases, Oracle, SQL, Microsoft SQL, Postgres, everything. It gets processed with the help of ADF, and with the help of any BI tool, such as many business intelligence tools like Power BI or Tableau. We can interpret the data. We can take out the advanced analytics on top of it. We can go also ingest it into machine learning models and take out any other insights from that data. And ADF helps facilitate all these things. It can help us doing the transformation, ingesting the data, doing the transformation, and also orchestrating all the pipeline, all the workflow. And what are the data factory processes? Let's go into it. So the basic thing is, like, as I already said, there are a lot of data sources out there. You have a number of data sources, a number of cloud services out there as well. You have cloud services from Oracle, Azure, AWS. Alibaba also has their cloud services. So you have to have a system which can ingest all those data. So ADF has facilitates that. It can ingest all the data out there. At least more than 100 connectors are present there, which that means like you can ingest all the disparate sources into your system. What will happen? First, you'll ingest it, and then you'll have to transform it. You have to prepare the data. You have to prepare the data, as in there will be a lot of data quality checks which can happen inside it, and then transform it, analyze it based upon your functional logic, based upon your data warehouse logic, data lake logic, or data mart, whatever is your end system. And then you can publish it, as I said, to your data warehouse or to any other sources or to a different uh, downstream system such as a machine learning model or something like that. And then also you can do on top of it, you can consume that data, the filtered data, the refined data. After the full process is done, you can consume it in a number of BI tools out there. So what are the components inside Azure Data Factory? So one of the component is linked service, then it's triggers, pipeline, parameter, integration runtime, control flow, and data sets. So I'll go through one by one in them. Firstly, I'll just give you a brief definition about them, and then I'll go to the portal and show you how it works, how to create a pipeline, linked services, data sets, integration runtime, everything. Okay, so let's go to linked services. As I said, you can ingest a number of data sources inside it. So how to ingest that data sources? So links service plays a role here. If anyone has gone through SSIS, then they would know that there's a connection manager inside SSIS. And this link service is equivalent to that connection manager in SSIS. Okay, so this basically helps you to connect to a variety of data objects out there, data sources out there. And this object inside Azure Data Factory is called linked service. As you can see here, you can have a number of sources here. We have a data lake store or a Databricks. You can connect to even the compute services such as Databricks using linked services. Then let's go to pipeline. Once the once you connect with the link services, then you have to create a data set. What is a data set? It actually represents the data structure within the data store that is being referred by the linked service object. So let's say you are connecting to Azure Blob Storage. Okay, linked service, you have created a connection for Azure Blob Storage. Okay, so then this data set it can comprise of let's say a delimited text file. Okay, so this text data set, you can think it of as a CSV file as well. Okay, that will comprise the data set, the data structure within the data store that is being referenced by the linked service. Okay, so this will act as your data set to the transformations in the Azure Data Factory. And then you have a pipeline out there. What you do with the pipeline, you have a different number of activities inside Azure Data Factory, which contains a transformation logic and commands so that we can do ADF work. Okay, and a collection of these activities are termed as a pipeline. They constitute a pipeline, and how you can trigger a pipeline, how you can run a pipeline is with the help of triggers. Then parameters, as you all know, we can dynamically provide, we can hard code our data set file names or let's say our output data. We can hard code it, but with the help of parameters, we can dynamically provide it. Those are also present in ADF, which I'll show you more. It will be more clear when I show you the demo out there. Then integration runtime, this is a very important thing. This act as a manager of all these services out there. It makes sure that our resource is allocated for these things. It makes sure that there's a connection between the activities out there in the pipeline, and a result is delivered, and exact result which is expected from the pipeline is delivered using with the help of integration runtime. It basically allocates all the compute server resources out there in the form of data integration units, which I'll show you. And control flow. Last one is control flow. It's an orchestration of pipeline activities that includes chaining activities like for each container. Uh, let's say if you want to go to loop through all the files which are present inside a particular folder, you can use with the help of go with the help of control flow, and many more things are possible with the help of that. Let's go to the demo. I think I've rushed through very fast, but let me show you. Let's first create a data factory. Okay. Let's first create a Azure data factory, and I'll show you how to create a data factory. You can go out there and search. I'm already there, but I'll still show you. Search the data factories, and then it will come out to again to this one. So I have already created a couple of them for this lab, but I'll show you. When you click on the plus create button, here you will get the pop-up with all the things like subscription. You have to enter subscription. I'll go with that as your pass. I have created a resource group for all the ADF work, Azure Data Factory work. Let's use that one. This region is very important in Azure Data Factory, because some of the region still does not support all the full functionality of which can be offered from Data Factory. So you'll have to correct uh, select this region very properly. I'll go with, I think, Europe. West Europe has everything, I think, yeah. And your name has to be unique out there. Data bag, and let's say ADF demo. Sorry. Demo 11. Here version selected as V2. We also have a version known as V1, but this is the old version of Azure Data Factory, but it's like very obsolete now. So I would suggest you to go with a V2 version, which in version V1, I think they did not even have uh, the graphical uh, representation of all the data flows and everything. It's a very old version. Next, go to with let's go with V2 now. Let's go to review and create. Okay, git configuration fail. Let's configure git later. We do not want to use git right away, but if you want, you can do it. There's also a possibility out there. So I've configured it, subscriptions, resource groups, region. Let's review it. Name, version, connect to public endpoint. It's open. So okay, the background, it will get created. Let's go to data factory. It's in progress. It might take some time. Have I created it somewhere else? Was it? Yeah, out there it is present. Data back demo 666. Okay, let's go through this. All the location, everything is mentioned here. Then you have one pop-up which will open the Azure Data Factory Studio in another tab. You can also go through the documentation out there. It's very good. And let's go to the dashboard for the ADF. Okay, so this is the main dashboard and you have a lot of options present here. First, to ingest, create a data, orchestrate, you can directly create pipelines from here, transform data, configure SSIS. I want to show you something. Okay, so there are many videos out there, tutorials out there, which are provided by Azure. You can go through them. It have a very very deep tutorials about all the steps present inside Azure Data Factory, data flow, Synapse Analytics, everything out there. You can go through them, and I think, but this is not required for your certification, but for your normal day-to-day life. If you are started working in ADF, then you will need it very often. There are tutorials out there as well, which you can go through. Okay, so this setup is done. I have shown you how to create a data factory and all the versions, locations, data center, which instance is needed. I'll show you one example where I created something else. So you have to see here the data flow tab is enabled, but if you somehow select some another region which does not support it, then you will get something like this. Here the data flows are disabled, so if you want to use it, then select it properly. In South India it's not available, in Germany West Central it's not there, so kindly select it. If not available, then change your region and it would be available there. Okay. This is something which I've been playing with already. So I've created a number of data sets, Power Query, pipelines already. And this is your demo version. You can create them as well. This is an option for adding a new resource. For pipeline, you can also create a pipeline from a template. But for creating a pipeline from template, you'll have to first create a pipeline and then save it as a template. If you save it as a template, then you will be able to reuse that pipeline again and again as per your requirements. Then there is an option for data set, as I explained. This is one of the components: data flow, Power Query, and copy data tool. I'll go through them one by one and I'll show you all the demos. But let's see what's out there in my slide first. So Azure Data Factory security. So I'll go through this and then I'll come back to the demo again. So to create the ADF instances, all the objects, linked services, pipelines, triggers, integration runtimes, and if you want to manage the resources with PowerShell or the SDK, then you must belong to the Data Factory contributor role. at the resource group level. Currently, I think I'm the admin, so I'm able to do. So if you are creating it, and if you are giving that if you are the admin of your Azure Data Factory, and if you are giving the privileges to some other guys out there, then you'll have to make sure that the correct role is set up, but you do not have to worry about it, because even in the real-time scenario, there are teams which will be taking care of it. So it's just for your understanding that you should have to be a contributor role at the resource group level. Then only you will be able to create it. So it gives you the permissions to create, edit, delete data factories and its resources like pipelines, triggers, which I already showed you. And also it can help you to create support tickets if you face any issues, in which the Microsoft team can help you out there. Okay, this was a just which I wanted to tell you about the securities. Now let's go to the linked services, which is the second important thing. Linked services, as I already told you, it's like similar to connection strings, which are present in SSIS. They define the connection information needed for data factory to connect to external resources. Okay, 100 connectors out there are present inside ADF, which you can utilize it to connect to any source which you want to ingest. Link services. There are two types: data stores and compute resources. So data source will be something like Azure database, blob storage, uh, anything which stores the data. Okay. Compute resources will be something like Spark cluster or Databricks, which you can use to which you can utilize to process to compute your pipeline. Let's go to the demo for linked services. How to create a linked service. Okay, so once you will go to the data factory portal, then you can go to, there are actually four things: home, author will help you to collapse it to create pipeline, data set, data flows, Power Query, uh, and monitor. You can see all my pipeline runs which I have done, all the trigger runs. I think I have done nothing here. Integration runtimes, I have already by default auto resolve integration runtime. I'll come to it. What do you mean by auto resolve and everything? And I've also have one self-hosted integration runtime. What is that? I'll also come to it as well. And then you have a manage tab where you can create your linked services, your integration runtimes, or your triggers. You also have option to create triggers inside your pipelines as well. But you also get a second option to create triggers here as well, where I have created one trigger already, but it's stopped. And linked services. Let's go through the demo for linked services. Okay, I'll show you in the new data factory which I have created. But if it takes time, then I'll switch back to my old one where it's already created. Okay, so let's create a linked service. See, as I told you, there are many data store services out there which you can utilize in Azure. Let's say it's too many: Zoho, Sybase, Spark, Snowflake, Salesforce, PayPal, UPI, API. Then there is compute services like Azure Databricks, Azure Machine Learning Functions, HD Insight, etc. Here you also have in data store, you also have the option for different Azure services out there: CosmosDB, SQL database, table storage, database. Then there's a distinction between all these database which are present. Like you can also connect to Amazon Redshift. Files like S3 you can connect to FTP, Hadoop, and some generic protocols you can connect to REST. NoSQL, you can go to MongoDB, Cassandra, and there are like many more like GitHub, Jira, and there are many more services out there. Okay, let's create something for Azure Blob. So we are creating a linked services for Azure Blob. I've selected it. Its name is Azure Blob Storage 1. Okay, here there's an option to connect to our integration runtime. So you can choose the integration runtime here. You can also create an integration runtime here, like self-hosted, Azure SSIS, or Azure, the three types which are out there. I'll go into deep in them. But here by default it is auto resolve integration runtime. What do you mean by auto resolve? Also, I'll go to that. Authentication method is account key out of this scope. And you can see the connection string here. Here you have to choose the Azure subscription. Then let's choose the storage account, which is already out there, Azure. Databag datasets ADF. I'll show you one storage account which I have already created. This is this one. Let me go to my resource group, and then I'll come to this storage account which is created. Inside this, I have a container, data bag blob, sorry. And I have uploaded few files here already. Let's be with the help of linked services, we'll try to read them. I'll show you what content it's present inside them. There are some customer related data like customer code, customer name, and some sales records present here. Customer2.txt also has similar, but it has less records, and there are different records here. Okay, and this is something which I've already done, part of some other process. So let's go back to our linked services. So we have already selected the storage account name, which is databag dataset ADF. Okay, and then let's okay, there are many other things to linked services to file path. So let's go to linked services. Annotations are similar to like tags which are out there. You can create an annotation here, and later on if you want to see, uh, think it of as a tags only. Okay, let's create, if you create an annotation here and tag it as databag demo. Okay, and then all the services, all the resources which you are creating, you can create the annotations as databag demo, and later on if you want to see what are the resources which you created as part of that annotation, you can easily get them. And if you want to do something on top of it, you can do it. If you want to search it, you can do it. So that's the usage of annotations. Parameters is also there, but I'll show you later on. And this is something related to JSON format. It's not needed actually right now. I'll create the linked service. Now linked service is created here. Okay. This is how you create the linked services. Okay. And if you create a link service, you have to also create a data set. Okay, it's not necessary, but of course, if you have to utilize it, let's say if it is something like a data store, as I already said, if it is like data store, then you will have to create a data set as well. And what's a data set? It's a named view of the data that simply points or references the data you want to use in your activities as inputs and outputs. So what we did currently is, let me show again, where is this link services? Sorry. Okay, so this link service, what it is doing, it is just connected to Azure Blob Storage and to our container, Blob container. And Blob container has many things like customer1.txt, customer2.txt. So if you want to read these two txt files, these two txt files can act as a data store, data sets. Okay, and link service helps you connect to that data sets. So data sets identify data within different source, such as tables, files, folders, documents. For example, in Azure, blob dataset specifies the blob container and folder in blob storage from which the activity should read the data. Okay, so we will be actually going through this again. We'll be creating the data sets from the blob storage which we connected right now. And also we have some demos out there where we'll be doing some transformations in the file and creating a new file as well, and we'll show you that as well. So a data set in a data factory can be defined as an object within the copy data activity as a separate object. I'll show you what that means. Okay, so you have created a link services, and you have to now create a data set. So data set is present here. Okay, so now nothing is present. There is nothing inside data set, it's all empty. So you can create a new data set here, or if you are creating a new, or if you are creating a new pipeline, then also inside the new pipeline you will create an activity, and inside that activity you will get an option to create a data set as well. But let's go through, we'll show you both ways. Let's first create a data set from this tab. Okay, it is Azure Blob Storage. Okay, continue. uh, I have a txt file and it is comma separated. So let's take a delimited text here and name this something like input source one. Sorry, input source one. Okay. Now we can utilize, see here, the link service is coming in play. Okay. So here we can utilize this Azure Blob Storage ADF, which we created. This is the link service which we created. And here is the path we might need to specify for the container inside this linked service, inside this Azure Blob Storage ADF linked service, which is pointing to a Azure storage account. What you can do is, if you remember, you can directly type it. If you don't remember, then directly go to this browse button, select it, and okay. So this one is populated. If okay, the scenario here is we do not have a directory here. We directly have created a data store container, data blob container, and then inside it we have all our files presented without any folders. Okay, so if you want to read a specific file, you can just click on this. Which one do you want to read? We want to read customer1.txt. Okay, let's select it. And this customer1.txt. Okay, let's see how I've shown the data. And this first row is a header. So we'll have to specify it, otherwise we might get some issues. So import schema from the connection. First row is as header. Okay, from sample file also you can create it, but then you will have, if you have a very big file and you have a schema of the, let's say this file is it's too big and you have too many columns inside it, or then you also have, you can also have a file with all the schema properties of that source file. So you can use that option that time. Now your data set is created. See here, you can see the link services, Let's test the connection. This connection is successful. Let me close this. You can edit it again. You can create a new link services from here. File path is here. There's also something called add dynamic content. I'll go through it in the parameter section. That's also something interesting. Here the compression type is none. You're not doing any compression here. Nothing gzip or something like that, so you don't need it. Delimiter here is comma. It's already present by default here, so let's use that. Row delimiter is by default \n. That is a new line. / a carriage return, but we have \n. It's already taken. If you have something else as a row delimiter, you can use it. You can specify it. Encoding is UTF-8. Other things are like normal. Escape character / if you want to escape it. Quoting character is double quotes. First rows as a header. That's fine. Null value is nothing. Now inside the schema tab, you have all the column names and their data type. Second. Okay, so schema represents basically the column names which are present inside your text file or whatever your data store is, and its data type as well. Then there comes parameters. In this one I showed you, there's an option called adding a dynamic content. So here the parameters role will come into play. I'll show you that, but I think let's go slowly. So this is a normal data set which we have created. Okay. Now let's go to, okay, first you'll have to validate all as well. Your factory has been validated. There is no issue. There's no compilation or anything which you have left, which is mandatory field, but you have missed it. It will come out there, but it's nothing. It's all good here. So if you want to apply the changes which you have done till now, you will have to publish it. Okay. If I publish it, let's publish it. Okay, it will be publishing. It will be deploying the changes to the factory, data factory. It should be quick. Deployed one resources. Yeah, it's published. So now you can use this data set in any of the activities inside data factory. Okay. So this is how you have to create a data set. I have given you an example for as your storage account. You can use anything as well, like let's say if you want to connect to Microsoft SQL Server, you can also use that. And there are many more things out there, a number of data sources out there which you can try it out as and when you have time. Okay. Okay, let's go to the next one. Data factory activities and pipelines. Till now I've shown you the linked services and data set. There are two more important things inside data factory, which are called activities and pipelines. Okay, so what is a pipeline? Pipeline, it's actually a logical grouping of activity. And what is an activity? It's what needs to be done. It's present inside the activity. For example, if you want to copy a data, there's a copy activity present out there. If you want to do the transformations, if you want to transform all the logic, all the source data, then there's a data flow activity present. And there are many more activities which are present there, Databricks, HT Insight, and many more, which I'll show you. And if you have to, okay, an activity, till now we have created these two things, link services and data set. So now this activity runs on this linked service. So if you have to ingest, if you have to copy something, okay, if you have to copy something, then this linked service will tell you where that file is present. Okay, and this data set represents on what you have to run this activity. Okay, so activity basically consumes the data set, and then it can produce a data set as well. And this data set represents a data item stored inside a linked service. I'll show you the demo for the uh, data factory activities and pipelines. In that, it will be more clear how these all four are related to each of them. But the basics were dataset and linked services. Now let's see how a pipeline uses this activity, or how uses this dataset and linked service. Let's go to the demo for pipelines and activities. Mhm. Okay, so this is our demo version. Okay, here you have the option to create pipelines by using inside the pipelines tab, or also you can directly create from here. Okay, both are same. Let's create from here, and let's name it all the same format, pipeline demo. Okay, this is the pipeline. As I said, there's an option. If you save it as a template, you'll get an option. You'll get an option to save your pipeline as a template so that you can reuse it. Okay, a number of times. You do not have to recreate each and everything. If you have created some generic pipeline, then you can reuse it. Okay, we mostly create routines which are common code or common pipelines or common transformations out there. So this can help you in reducing your workload. Okay, and you have an option to trigger this pipeline using this. This is also something which we'll deal with in depth. And let's explore more here. See, as I said, there are activities and pipeline. Okay, a pipeline a pipeline is a logical grouping of activities. Okay, what are the things which you want to do? So you have created a pipeline, and these are the activities, okay, which you want to do. First is a move and transformation. You can do a copy data. You can just drag and drop it into the console. Okay, let's first discover this pipeline. Okay, so again here you can see a parameter tab. It is actually used for dynamically creating parameters, dynamically attaching parameters with your pipeline. Let's say you have to copy 1,000 input files from one location to another location. You cannot create 1,000 pipelines, okay, for that one copy. So you can create a parameter, and dynamically you can provide all the data there. Variables is normal, settings and output. I think I'll show you when when the pipeline will run, it will get the tab populated there. This copy data step I will also go in depth, but just I'll show you what are the things present here. General, name, timeout, retry option is available inside your pipeline. You can retry if just think like you have triggered your pipeline and you got some network issues, or okay, and your pipeline got stopped. So for that cases, you can use this option. You can retry it. And what will be the retry interval? Let's say after 30 seconds, you want to retry it. If your network services are again up after 30 seconds, you can retry it. And if there's no any other issue, then your pipeline will continue to do its work. Uh, then there are other options which I'll go through in depth later on. There's an option called source. Here you can mention your source data set. Here you have created a data set here, input source one, and see it is getting populated here. So you can use this as a source data set, or you also had an option to to create a data set from your pipeline. As I already told, you can create a pipeline data set from a pipeline as well. So if you click on the new tab, it will you'll have the option to select it. Let's create one data set from here as well. Okay, and we'll use it as a destination or something like that. If we have one more file, we can use it. Let's use again delimited. The same link services, same thing which you did from the data set tab, you can do it from the pipeline as well. You have selected both. Select as a header. Okay, it's done. Oh shit, I didn't rename it. Delimited tech doesn't look good. Let's name it input source 2. Okay, so your source, let's click. Okay, so once you created here, it redirected to you to here. A data set is already created here. Okay, so you can test out your connections. It should be fine. The things are same: comma delimited, row delimiter, encoding, back, escape character. Everything is same here. Okay, let's go back to our pipeline. As I showed you, this is one of the things in copy data which is present. Then there's an option called data flow, which we'll also go in depth here as well. Data flow helps you to create a number of transformations. Uh, let's say if you have two source files, you have to do some joining. Okay, in a normal scenario, let's say in my day-to-day life, we handle a data warehouse out there, and we have a number of source files which comes in. They're like 180 source files which comes in. They're all different, but they are all majority of them are connected to each other. Okay, so when the files are connected with each other, you have to do some joining out there. So those transformations you have to do, and there are number of database lookups you will have to do, or a source file lookups you will have to do. Or data is present in one file, it's not data is present in one table, and you have a key with it, and you have to do lookup with it. So I think most of the guys should be aware of that stuff. Okay, so those are the basic things which are present inside data flow. All the data transformations you can do with the help of data flow. I'll go in depth later on. And there are many more activities like data explorer functions, HD Insight, then control flow activities like these no iterations and conditionals like this. For each if condition switch until your normal programming logics are coming to play here. For each, you can just loop through files which are present inside the folder. Normal basic example for it is if conditions. You already know, for example, if you have to go through, there are two flows and you have to go through them. You can use if. You can go to switch based upon the conditions until. You can traverse through the loop until you have a condition met. Machine learning and Power Query. Power Query is basically for data wrangling. I'll show you that as well in depth. And Azure Functions, batch services, Databricks, which is like compute services also, you can use it. Okay, these are the activities which are present inside a pipeline. Okay, so these are all you can go through it. So what are the things important? I'll tell you. If you want to go through it in depth, each and everything present inside data flow, you can refer to the tutorials which are present inside the uh, Azure documents. Okay, so what we have done till now is we have created a copy data step. We have created one more input data set. Okay, let's validate all. Okay, so sync data is required. It's telling us, okay, that's good. We are getting some suggestions in the validation. That's what I wanted to show you as well. So this copy data, you have already provided a source, but you have not provided a sync. Sorry. You're not provided a sink. A sink basically means a target data source. Okay, so you have, what does this copy step do? Does it copies the data from one source and it copies it to another data source. It can be like, what we are doing currently is we are reading a text file, okay, a CSV file. What we can do is we can copy that CSV file to a table storage, okay, and that will we can copy a CSV file from we can copy a CSV file and we can directly create an output file. We can dump its data to a database or anything. There are many things which you can do with it. So sync will help you do that. Okay. So this is not done. That's why it's giving you error. So you won't be able to publish it properly. Okay. So for this one, we'll have to create one more data set, which we'll deal with it later. So I think this should be clear to you guys now. We have created pipeline. So we have already created a pipeline. We have created activities. We have created dataset, link services, and they are all interlinked with each other. They are all present inside the data factory dashboard. Okay, portal. Activity suggesting you what needs to be done. In simple terms, just remember it as activity which suggests you what needs to be done. Data sets want what the activity needs to be done. It's suggested by a data set. And linked services tells you where you have to do that activity. Okay, on what, where you'll find that data set. That acts a connection string to a data store or connection string to a compute services as well. Okay. Okay, let's go to integration runtimes. Okay, so this is the major thing which is doing all the computation, all the things in the background for Azure Data Factory. This is very important. Sorry. Okay. So there are three types of integration runtimes: Azure, self-hosted, and Azure SSIS. Okay, so since I already told you, this is similar to the this ADF is a cloud version of SSIS. SSI has a lot more capabilities since it's an on-premise tool, and it is like from it's like for many years it's out there, so it's well developed and well matured. But this is I think this is just in their initial phases. So integration runtime types are like three types: Azure as self-hosted and Azure SSIS. Uh, okay, we can explicitly define the integration runtime setting in the connect via property, as you were able to see when we were creating the data factory. You had an option to select the runtime. So you can select the integration runtime from there. By default, it goes to auto resolve runtime, integration runtime. Okay, let me show that. This one is yours. No, this one. This one is mine. Let me go to here. Okay, so see, when you created our data factory, by default, this is integration runtime was created. It's already running. It's auto resolve integration runtime. Okay, it's public auto resolve. Region is auto resolve. See, what happens is, uh, let's say I'm currently in Europe. Okay, so if I'm currently dealing with my clients are bank. Okay, so we have to deal with the data which are governed by regulatory bodies. So there can be some kind of uh, regulatory rules that your data which are arising from, let's say, Europe should not leave Europe. Okay, so then you have an option to create a self-hosted integration runtime where you can select your region. Okay, if you select your region there, then it will not flow to other regions out there. Okay, and but this auto resolve, it automatically resolves the region for you. You don't have to do anything, and it can take anything. If wherever it gets a good latency, or wherever your resource are deployed to, it will automatically resolve it based upon its convenience, Azure convenience. Wherever it thinks it's good, it will go to that. But if you have some rules, regulations out there under which you have to design a pipeline, then you have the possibility of creating uh, similar to that runtimes. Let's say self-hosted. I'll go in depth for self-hosted as well. This, as I said, this is Azure one. There are of three types of integration runtimes. First is Azure. So this by default one is Azure one, and this one you won't see anything. Self-hosted, you won't be able to see anything. So if you create anything in self-hosted, you will be able to see the integration runtimes for that. So let's create runtime. Let's create a self-hosted runtime. Okay. Runtimes, integration runtimes. Here it is. Where am I? Okay. Let's come back to here. Here you can already see auto resolve. Sorry. Yeah, auto resolve integration runtime. Let's create a new one. Two options. You can get two options to create Azure self-hosted and Azure SSIS. There are actually three. This one is Azure. This is self-hosted. This is Azure SSIS. Let's create. Okay, so this Azure SSIS is basically used for uh, uh, executing all your SSIS packages which you have already created, and you just want to lift and shift and run it in Azure. If you want to do that, you can directly use Azure SSIS integration runtime. Otherwise, you can use Azure or self-hosted. So let's go and create this one. Okay, so this one is Azure. Use this for running data flows, data movement, external pipeline activities, and a fully managed serverless compute in Azure. Okay, and this self-hosted is used for running activities on-premises or private network. Let's use this one. Okay, this no one has taken that name, so you will get this option. Okay, so okay, this one is automatically created, but what will happen is this will be disabled. So you'll have to download this setup for it. Download and install your integration runtime on your machine, or if you have a server out there, if you're in a practical environment you're using it, then there might be some servers or machine you can use it. There's an authentication key given here. You can utilize that for this setup purpose, and then it will be linked. Okay, I'll show first this self-hosted, and then we'll go further. Okay, so self-hosted runtime is this one. So if what I did is I create for your purpose, I have downloaded it because it will take some time to show here. So I've already taken the screenshots and I'm showing you. So if you'll go click on here. Okay. You'll get an option to download it from the site. Sorry, here certain language English. When you click the download button, it will download you a exe file, and once you click on the installations, you will get this window where you can put in your authentication key. Once you have put the authentication key which you got from here, you can copy it and put it there. It will give you a green tick. That means you are registered. You'll have to basically register it. It is registered. So you can see integration runtime node has been registered successfully. This one. Okay, and then self-hosted node is connected to the cloud services. Okay, then you have to launch the configuration manager. Once you launch the configuration manager, you can see my details out there, but it's a self-hosted integration runtime. Inside it is connected to my data factory. It is on premises, it's in sync. If you do anything, it will you'll have to sync it up as well. Okay, so this was the demo for the integration runtime. For self-hosted, there is an already Azure, and if you want to use SSIS packages, then you can directly use this SSIS runtime. And this is important. You can expect some questions from this as well. This integration runtime. So this IR type is 3 types. I've said this. If you have to specify where you have to use which integration runtime, this can provide you. This can help you as a guide. I have a good diagram out there as well. If you have a private network, which is, and you have to just do your SSIS package execution, just go with Azure SSIS. If you have a self-hosted network in your on-premises, you have to do some data movement or activity dispatch, you can use self-hosted. Or if you want to use public network basically here means the cloud service. And if you want to use, you can use Azure integration runtime when you are using, if you want to do some data flow activity, data movement, or activity dispatch. Total, there are 4 different types of integration runtime activities, which are data flow, data movement, activity dispatch, and SSIS packet execution. So this public network, you can use it when your sources and your destination all are in cloud, like the thing which I did. For me, everything is in cloud, so that's why we have we have a auto resolve integration runtime, which is basically an Azure runtime. See, as I told you, we won't be able to make it up because I haven't installed it. I haven't installed the self-hosted one, but if you install that package, then this status will come to running. See, as per my setup, you can see it. It is running because I already have the setup installed, as you can see in my screen. Okay. So as I said, there are 4 different data integration capabilities. Data flow, to execute a data flow in a managed Azure compute environment. Compute environment can basically mean you are utilizing Databricks or anything else. And data movement, basic simple example for this will be a copy data activity or activity dispatch. Here you can dispatch and monitor transformation activities running on a variety of compute services, such as Azure HT Insight or Azure Machine Learning, SQL Database Server, Databricks, and many more. SSIS packages, as I said, they are basically natively execute SQL Server integration services package in a managed Azure compute environment. I'll zoom this one. Are you able to see? A bit hazy it might be.
Yes,
okay.
we can.
Okay. So there is a distinction here. I've given a line between the cloud and the on-premises. Okay. Okay, so all the 3 different Azure runtimes, how you want to make sure that your concept is clear and what you want to use and which situation. This diagram will actually help you out in there. See, as I said, if you want to use Azure integration runtime, then all your data movement or your compute activity dispatch, source, your destination, everything is present inside Azure cloud. Okay. Uh, okay. And the next one is integration runtime SSIS, Azure SSIS. Here, what you want to do is you want to just execute existing SSIS packages. So as I said, if anywhere you comes into a scenario, you come into a scenario where you have to execute the SSIS packages, then just use, without thinking, you can just use Azure SSIS. Okay. Here the scenario is like everything inside cloud, but still it is you have to execute the SSIS package. So that's why you can use, you should use actually Azure SSIS integration runtime. Then let's go to this virtual network inside Azure. So here you have an integration runtime which is self-hosted. You are using a self-hosted, which is inside a virtual network. If you want to specify your regions and all, then go with self-hosted. And inside this virtual networks, you are using Azure SSIS. As I said, if you have to execute SSIS package, go with Azure SSIS integration runtime. There's no need to think about it. Here, your source was in cloud, destination was in on-premises. You can go with integration runtime SSIS. And this self-hosted, here you have everything inside in your on-premises, but your source is present inside the cloud, but your destination is in of on-premises. You can go with self-hosted one here. So if you get questions from this, then I think you will be able to handle them properly now. Okay, so we are done with the integration runtimes.
I think there is a question in Azure IR. There is no control on which compute is located. That is which regions. That's a question. I mean, when it comes to integration runtime of Azure, can you specify the location where you want to run your IR? But I think it's possible, right? So you can select the location while creating a Azure integration runtime. I think you might have missed showing that. If you go back to the integration runtime, Vishwa, just try to create one new integration runtime here.
Okay, I can show you.
Oh, you already have it?
No,
I don't
there
think
also
you
I
haven't
did not
created.
select it.
Yes. Maybe just try to create a new integration runtime.
I'll have to do the setups. Okay, here actually I did not go through these things. Okay, so you have an option here as well. Nodes. Okay, let me go back to my thing. This is already set up. So here you have nodes. There you have nodes. This is my local node which is running. Auto update. There's an option to auto update them.
So this is for the self-hosted IR, right?
Yeah.
So if you try to create a new Azure IR, let's try to do that. If you go to a new Azure IR.
There, I think I got the option.
Yeah, here if you try to click on that Azure, yes. Here you see the region.
Yeah.
So here you can select in which region you want it to run. Like you mentioned, right? So there might be some compliances and regulations, right? You don't want your European data to be outside the European, like you mentioned. So I think this answer is for you. I'm not really sure how to pronounce your name, but yeah. So the answer for your question is you can select the location, but it is only for Azure. Because here you need to make your concepts very clear when it comes to IR, like Vishwa mentioned, right? These concepts are really important with respect to exam and also with respect to regulations, because you might be working with your global customers, let's say US customers or Chinese customers or European customers, and they don't want their data to be in different regions. Of course, it is in the cloud, but still they don't want their data to be processed in different regions, because here the computation we are using, would you yeah, so here the computation you are using is from the shared resources, like the data centers which are located in different regions. If you wanted to use a computing power or processing power which is in London, for instance, so you have to select that region. Let's say your data is located in Amsterdam, because we have GDPR compliance, and now you're trying to create an IR which is located in India. So here what you're trying to do is you're moving the data, because you're trying to utilize the processing from power from India and trying to compute the data which is located in Europe. So that is not suggested. So you have an option to select this. And would you in any case use auto resolve? Yes. Again, that depends, right? That depends. Let's say if you don't have any issues with the data compliance or any issues with the data security part, right? If you have no issues like, data can move anywhere, then by default, anyway, auto resolve is created for you by Azure. So you don't really have to explicitly go and create an integration runtime. So by default, it is created, then you can use it. So that should, by default, Azure will pick the closest region or the cheapest region because now it's their business. Now it's their headache to use the integration runtime. So based on that compute structure, they'll use it. Okay, so the third question, just to clarify, will the local node in self-hosted IR be doing the processing? This is kind of tricky question. I agree where this is coming from. But here, Vishwa, do you want to take that question or? So the question is, once you create self, was it like self-hosted?
Will the local node in self-hosted IR be doing the processing?
So
Okay.
I think once you create a self-hosted IR, right? So you are integrating your integration runtime with your local node. So here, which compute process will be used? So as far as my knowledge, because there is little thin layer between this again. So as far as my knowledge, it should utilize, right? Because you are trying to load the data from your local machine to cloud. For instance, just assume this is a scenario where you are trying to copy the data from your local machine or from your local data center to cloud. So in this case, you have created your self-hosted integration runtime. So it is very straightforward, and it makes sense as well that when you are trying to load the data, you need your local computing power. You need your local computing processing, right? So here, 80% of the processing will be utilized from your local machine. And once the data is loaded there, it has to be structured in a format. So 20% will be utilized from the Azure. So it's like 80, 20, 70, 30, but here both are in sync. That is the reason you have an option where you have that sync. And it is also same when you create your private network, right? Within Azure, you also can create your own private networks like VMs and all. So in that case also, you utilize your self-hosted IR. So there also you'll be utilizing all the computing resources of your private network. So to answer your question in a single line, it will be using the on-premise processing system, all the computes. Maybe a way to go when practicing for the exam. Okay, the other question, maybe a way to go when practicing for the exam to go with self-hosted, maybe the price will not skyrocket. Yes, correct. I agree with you. But for practicing, I don't really think, they'll be utilizing much, because for me, based on my experience, especially with respect to exams, right? So while practicing, you will create IRs, but they don't really consume that much, because you create and you understand the concept, then you delete the resource. So it shouldn't be an issue. But whenever you're trying to, because here, most of the use cases will be dealing, right, with small scale companies or with new companies who wanted to migrate their data or migrate their applications to cloud, right? So what they wanted to do is they have their local data, now they wanted to send to cloud. So in those situations, you use Azure Data Factory, and in that situation, you use self-hosted. So here the objective behind what Vishwa explained, right? So here the objective is for you to understand you have different types of integration runtimes, and which integration runtime has to be used when. So Vishwa, if you go back to the diagram which you've showed, that really explains clearly, right? The line diagram. So yeah, this really makes things very easy, because if you see, you have on-premise, you have cloud, and if your data is in on-premise, now you wanted to move to cloud, right? Then you use self-hosted, and everything is in cloud, then you use Azure. And if you already have your legacy SSIS packages, like, SQL Server Integration Service packages, which you are already created, then you wanted to run them, right? Because you also have a direct integration. Here, Data Factory is nothing but a cloud version of SSIS. If you know what is SSIS, it is very easy for you to understand. If you don't know what is SSIS, try to do some Googling, but SSIS is nothing but SQL Server Integration Service. It is a Microsoft ETL tool, which was there in the market for many years. And now they have made some changes to that and enabled a cloud version and renamed and rebranded as Data Factory. If you already have, because there are so many customers who are already using SSIS. So for them to make it very easy to run those SSIS packages, Azure provided that, okay, I also added an integration runtime, which is called Azure SSIS. Utilize this and run your SSIS packages. So whenever your use case is SSIS, use Azure SSIS. Whenever you have on-premise data to be migrated, use self-hosted. Whenever all the data is located in Azure, now you wanted to move between your blob. Now you wanted to move data between Data Lake, Azure Synapse. Now you wanted to move data between Azure blob storage or Azure Data Lake, then to Databricks, then you use Azure. And that is one thing. And the other thing is whenever you wanted to take care of your region, right? Your data is located in a specific region and you wanted to use the computing resource from that region and you don't want your data to be going outside that region, then use Azure. Okay. And you don't want to take all this headache, then just go for auto resolve. You don't really have to worry. So in a nutshell, that is about IR. Just try to understand in IR very high level, because like Vishwa said, you might get questions. You will definitely get questions on this. Okay, thanks for your patience, guys. So I think let's resume the remaining concepts in tomorrow's session, and we'll also start a Databricks, and we'll also start Azure Stream Analytics in tomorrow's session.